Hi everybody, I'm Ben, and in this video I'm going to show you how to use R to conduct a t-test. It couldn't be simpler. So let's look at, we're going to be looking at the Q2 data. So if we look at the variables in Q2, you'll see one thing that I've done is we have party, and if we get a frequency table for party, we'll see that it's a two-group variable. Dem 354, Rep 252. So of course that stands for Democrats and Republicans. And then we also have in this data set feeling thermometer for supporters of the Democratic Party and feeling thermometer for supporters of the Republican Party. So I bet you anything that Democrats like supporters of the Republican Party less than Republicans do. Let's find out by running a t-test. To do that, you just need to type t.test parentheses, then put your outcome variable, which here would be ftdem for feeling thermometer towards supporters of the Democratic Party, then tilde, then your grouping variable, which here is party. Then data equals Q2. And you run that, and it gives you your output. So it tells us that T is 19.719, degrees of freedom are 432.02, and the p-value is 2.2 to the 16th, meaning that you would remove that decimal over 1 and then 15 zeros, which means that the p-value is much lower than 0.05. It also gives you the mean in group Dem and the mean in group Rep. You see that Democrats give the supporters of the Democratic Party about a 77.5, and Republicans only give them a 38. We can do the same thing for feeling thermometer towards supporters of the Republican Party, and I bet we will find that it is inverted. And we do see that Republicans give supporters of their party a 76, and Democrats give supporters of the Republican Party only a 37. We can also infer that how people feel about the outgroup is roughly equivalent, where Republicans give supporters of the Democratic Party a 38 and Democrats give supporters of the Republican Party a 37. But I've already created an outgroup feeling thermometer variable right here, feeling toward the outgroup, and we can test to see if those apparently similar numbers, 38 and 37, are statistically indistinguishable. So we can go t.test, feeling thermometer outgroup is feeling thermometer outgroup, yep. Comma party, comma data equals Q2. Run that. Oh, what's going on here? Feeling thermometer outgroup not found. What did I do wrong? Should be right there. See if this works. Run. Nope. Let's see if there is. Describe Q2 feeling thermometer outgroup. Run. It's in there. Oh! Aha, I was using a comma and not a tilde. See, I bet you were screaming it at the screen. By the way, it works if you do it this way too. And if you don't want to do data equals, you can do Q2 $sign. And if we run that, so it was mad at us because I was not using the tilde. That's why you always copy paste, right? And here it says, okay, Democrats give the outgroup a 37, Republicans give the outgroup a 38, and you'll not be surprised to learn that that difference is not statistically significant. Now, one thing that you might think is funny is that we're getting a degree of freedom that's not a whole number. It's 527.9. And that's because by default, R is correcting for the homogeneity of variance assumption. It's not saying you violated the homogeneity of variance assumption. It's saying we're giving you the answer to a t-test that does not assume homogeneity of variance. Basically, here the people who do the stats package in R are saying, why bother assuming homogeneity of variance when you can do this Welch two-sample t-test that doesn't assume homogeneity of variance and it gives you a good answer. But let's say for some reason you did want to assume homogeneity of variance, or you knew that assumption was tenable and you wanted to run a t-test that didn't apply the Welch correction. Well, you could just do var.equal equals true, and it'll give you a two-sample t-test without that Welch correction. And notice the degree of freedom here is 603, but also notice the p-value is basically the same. The t statistic is basically the same, and we don't have any different answer in terms of our, it gives us the same answer. So that's probably why the people who wrote the stats package here opted to just apply the Welch correction by default. Okay, I guess the other thing I can say is that the t-test function is in the stats package right here. So if you wanted to like read or learn about it, you could click on the stats package and click on the T to go down to t-test, and it gives you the arguments and whatever information you want about t-tests. Also, if you're ever curious about a package, you can just do question mark, or a function. You can just do question mark and then type the name of the function, and it'll bring you to this help page. So it'll show you that it's in the stats package. If you ever forget what package a function is in, or if you're getting the error cannot find function, then that little question mark is always helpful. Okay, I think that pretty much covers what we need to know about t-tests, probably a little bit more, but hopefully you found the video useful.